I checked that I think that more or less all the speakers are present. Just one, I don't see him.
Christian is.
Christian, yes, Christian is also present.
Yes, I'm here. Hello, everyone.
Hello, Christian. I'm sorry, there was a mistake in the starting time of the panel. The actual starting time, it was the original starting time was 10:45. Now that we are a little bit late, it will be 11. But on the program that is on the website, it's 11:15.
Okay, but at the end we are all here, so fortunately we don't have problem.
Was a misunderstanding with Giorgio, but
yeah, my fault, Guido.
I don't know, but it may I had to deal with a lot of hours timetables, so it probably was my fault. But in any case, it means that we have a little bit more time. So we are planning to finish around 12:30 in any case.
Okay. May I start sharing my introduction?
Sure. Please go ahead.
Can you see it?
Yes.
Okay, good. So, shall I start, or we have to wait still a few minutes?
Did you find all the Germano is?
Yeah, he's present. I think that only Juan Pedro, I don't see him in the list, but the other speakers are already present.
So now Germano is also presenter.
Yes.
Yes, I am.
Good morning. Yes, we miss.
Good morning.
Juan Pedro. I think maybe we can start, and as soon as we see him,
okay,
we can join.
Also, Juan Pedro is not the last one, but the second last, and maybe we can anticipate Christian speech, but I don't think it will be the case. Okay, shall I start?
Sure. Please.
Okay, good. So, good morning and welcome to the industrial panel. First of all, I would like to thank you, the organizer, in particular Guido, to give me the opportunity to chair this panel, and also thank you to the speaker for their availability to share, I would say, their experience, and hope we'll have an interesting discussion. The panel topic is about open solution for the next generation of telecom infrastructure, and I think that in this panel we would like to address the issue of integrating and evolving proprietary solutions that are in the past the normal solution for telecom networks, with a new virtualized, open, disaggregated, modular solution. And in particular in this industrial panel...
Giorgio, yeah? I think you are not sharing the slides anymore.
Ah, sorry.
Consider if you put full screen, your slides in full screen, and then exit full screen, you automatically stop the share.
Okay, I didn't know this. Sorry.
Okay.
And okay, so can you see them now? Yeah.
Yes.
Okay, so in this panel, we want to address and to discuss about the challenges for industrial products and applications related to this, let me say, new way of virtualizing and provide open solutions. I would like also to mention that this topic has been inspired by the Intento project that as Osmotics we have in Puglia, and where we are developing some experience in this kind of environment. I propose here a picture in order to try to better focus on the topic. In particular, I think that the major player for this are telecom operators, telecom manufacturers, and these open frameworks, alliance and standards, where also the universities, research institutions are playing, let me say, an important role. So we have some input from the market related to new application, related to reliability and sustainability of the infrastructure. And following this input, telecom operators mainly generate requirement for telecom manufacturers and for open framework alliance and standard. In particular, telecom manufacturers are asked to provide reliable solution, very effective and low cost. And at the same time, we have let me say, the requirement of providing open solution, possibly vendor independent, and disaggregation modular are other characteristics of those solutions. So this, let me say, environment, this situation generate two, let me say, competing challenge and requirement. From one side, we need to integrate general framework, very complex, with different, let me say, interfaces and models from one side. And from the other side, we need to provide a very efficient solution. And so this is not always, let me say, possible, and this kind of challenge are in some way in competition. So in this talk, in this session, we have, let me say, the contribution of some of the relevant players in this field, and in particular, we have two contributions from the, let me say, standardization and alliance. One from Vittorio Curri in representance of Telecom Infra Project. One other from Andrea Campanella related to Open Networking Forum. Then we have two, let me say, testimony of industry, and in particular Achim Autrich from ADVA and Germano Gasparini from SM Optics. And finally, we have two, let me say, experience, two testimony from Juan Pedro Fernandez Palacio from Telefonica and from Christian Yaknet from Orange. My goal is that we will look at this, let me say, experience, and at the end of the presentation, we can develop some discussion between the panelists. And finally, hopefully, we will have some questions and comments from the audience. So this complete my introduction, and I give the floor to Andrea, which is to Vittorio, which is the first speaker on Telecom Infra Project. And I ask the speaker to stay more or less within 10 minutes. We have a little bit more time, we discover, so, but I think that with 10 minutes is a good schedule for having some discussion at the end of the presentation. Please, Vittorio.
Oh, sorry, I was muted. Sorry, I was speaking to anyone. No one. So, sorry, I have to. So, can you see my screen?
Yes.
Yes.
Okay, sorry for the inconvenience. Okay. Now should be full screen, okay?
Yes, it is.
Okay, thank you. Thank you, Guido. Thank you, Giorgio, for the invitation. And so today I will quickly review what is the approach of the Telecom Infra project to opening up optical networks. And just to introduce, I'm a professor at Polytechnic Torino and also the scientific chair of the GMPY project of the Telecom Infra project. The Telecom Infra project tries to, is one of the institutions, the entities that are trying to address what Giorgio has introduced. So to go towards the openness and disaggregation of network in general, and specifically in this case, optical network. So why we need this disaggregation? In order to have a more cost-effective solution to future networking, and how to say, the request for operator is towards openness and application of multi-vendor open software defined solution down to the physical layer and optical network is the main request is to squeeze out all the possible capacity for the installed infrastructure, and has been extensively proven also in other fields that opening up, going toward disaggregation, enable to better exploit the infrastructure. There are different, several institutions working in this direction. Other institutions like Open RODAM or Open Config Consortia work in standardizing interaction. Telecom Infra project works in opening up hardware and software. The idea, specifically in optical networking, is to completely virtualize the physical layer, the optical transport, in order to have what we like to call the digital twin of the optical transport, and so to enable management optimization of the transport in an open and modular way. So we want to go towards a sort of Lego block optical networks. So a short overview of the structure of the Telecom Infra project. And here are the working group that follow the disaggregation, vertical disaggregation interaction also with wireless solution of the optical network. And so we start from the physical layer and we go up with the control and network operating system and in general, so putting together different components. Specifically, we operate in the physical simulation environment. So what we need for an optical network, we need this digital twin, and so there are different blocks. So we need, of course, open pluggable interfaces, and we are going in this direction with 400ZR, ZR+, and open boxes transponder, and in TIP we have Cassini supporting pluggable 100G and 200, and Phoenix for 400. We need open RODAMs, and open RODAM is working in modeling RODAM. Open RODAM to RODAM optical line system control, then multi-vendor optical controller for the entire network, and these imply, and the tools are software tools require the vendor agnostic design and planning tool, LiPath computation engine that goes down to the transport, open models and protocols and API, and this is the ecosystem that we want to build, and TIP Telecom Infra project is covering many of these aspects. Other institutions are covering other aspects, and so we are going toward a convergence in a possibility of software-defined open optical network. Going down to the physical layer, so what we propose is the digital twin of the physical layer that is a weighted graph, topology graph, and so given the description of all components, we get this with weighted graph. Navigating this weighted graph, we can abstract transport through an API that is the quality of transmission estimator. This framework is covered by the GMPY project in the Telecom Infra project. Given this, we can estimate many meters for each transparent light path, so the GSNR giving performance and latency that will is and will become more and more urgent to address in convergence with 5G traffic, in supporting 5G traffic in optical infrastructure. So in this way, we propose to use this abstraction of the entire physical layer infrastructure in order to enable by the network controller a full optimization or tailoring of the layer functionality, so within a SDN environment, and so toward the virtualization also of the WDM optical transport function. Does it work? We have done extensive tests, so I'm presenting here one that we have done together with Micros. This is the layout of the greenfield optical network they have in the Seattle lab. And what we have done is to compare if this method works. So is the actual digital twin, this software that enable calculation of performance, compared to what you read on the field in the hardware, so it works. So we have done this test, multi-vendor. Actually, we have done two tests, and so we have taken from the SDN controller of the Micros network the network description. We have provided to GMPY. We have estimated by GMPY the GSNR over the transparent light path, and we compare with the measure one. Result has been really comforting, and here is a plot of the accuracy that is really good for different modulation format, different distances, and so on. So we have done also testing in brownfield together with Microsoft on a portion of the core network of Microsoft. We have done also many other testing of the core of this code. And so which application? So this is the physical layer, what we like to call digital twin, but how to apply it. So first application is a vendor-neutral network design and planning tool that supports multi-vendor disaggregating network. So in this term, operator can test different solutions in a virtual environment, can interact with different vendors in order to optimize and minimize cost for the network infrastructure. And then the other application is the LightPath computation engine. So this quality of transmission estimator can be used by the network controller in order to understand, to predict, compute what is the actual performance available on a transparent light path in a multi-vendor open network. This way, also thanks to the open optical interface like 400 ZR Plus and ZR, so you can, or similar, you can deploy the best possible solution in terms of capacity, and so squeeze out all the possible capacity from the physical layer. And also in terms of control. So the optical layer control is a fundamental building block in optical network, and so instead of private control of lines, you can or dedicated control and closed control of the lines, you can exploit in this software. You can deploy. Think about deploying a multi-vendor or vendor-agnostic, vendor-neutral control, and so to enable multi-vendor network where different optical domains are covered by different vendor working in optimized way. So which are the results? So in terms of design and planning tool, Orange has already used GMPY for design and developing a portion of the network, specifically the West African Backbone project. So this is something that is prosecuting, and also there are deployment in South America and other area of the world that has been done, planned, designed and planned using GMPY. Other applications are, and we have done, and we're still doing some development and integration with open network operating system, and specifically with ONOS, together with Andrea, that will speak right after me. And then we have done a couple of demo at TIP Summit 2019, OFC 2020, and we'll have a demo at OFC 2021. And demo are in the full integration, and also in the including young models for the fiber and common API to be used by the network operating system. And so we are prosecuting in this direction. The other direction we are working on is in the tip in general is in controlling multi-vendor network. This is a POC that has been presented in 2019. There are other that are under development, and so we have different network segments covered by dedicated and closed solution from different vendors, and so we put together these different network segment and orchestrated and controlled by open software, open interfaces. Okay, here is a description of the specific implementation. So to conclude, and thank you for the attention, to conclude, so where we are, and thanks to the Telecom Infra project, we are prosecuting toward the openness of the network. We are developing open hardware and open software, which are the missing points. So of course, there are still the need of standardization, on enabling dialogue, but all the bases are available, and so we are fast prosecuting and to enable this openness and disaggregation in the optical network, starting from the physical layer. That's all. Hopefully, I've been in time.
Yes, for sure. Thank you, Vittorio, for your presentation, and I will propose to reserve questions at the end of all the presentations, so we will have a clear, let me say, overview of all aspects we are addressing in the panel. So I would like to ask Andrea to take the floor and do his presentation.
Hello, everybody. Yes, allow me to share my screen.
Good. You have already a possibility, Andrea. You can...
Yes. Can you guys see my slides?
Yes, we see some colored waves at the moment.
Oh. Just need to find the window. Apparently Teams doesn't like my screen very much.
I know it's always difficult to find the window to share.
There we go. Okay.
It's okay.
I hope you guys can see.
Yes, now it's perfect.
Hello, everybody, and thanks for joining. I'm Andrea Campanella from the Open Networking Foundation. Today, I'll talk a little bit about our deployments and trials of our software in production deployments of the operators. And so ONF, for those of you who are not terribly familiar with what we do, we transform wireline and mobile access edge and core networks, starting with all open source networks. It's based on almost the SDN controller on the bottom, and we change wireline, mobile, and backbone with our different projects, Volta and SDBNG. Here on the left side, in the mobile network, we use SD-WAN and OMAC projects. In the backbone for the data center interconnect, it was mentioned by Vittorio, we have ODTN. So with ODTN in particular, we went in the field in a first successful field trial in 2019 in South America, in Peru. And it was in collaboration with TIP, EdgeCore, IP Infusion, and Lumentum. And we managed 2 Cassini devices to OpenConfig for discovery and provisioning of wavelength power and modulation. The trial was successful. We learned a lot. You guys can find more information in here. And this is one of the trials and for the disaggregated optical network that really shows how this is a complete and powerful solution that can be used in production. We learned a lot of lessons. I'll talk about those later. Another success story that we had and where we learned a lot from production deployments is the use of Trellis, the leaf spine fabric at ONF. That's all managed by a single ONOS cluster, 3 node instances that can manage up to, usually the deployment is a 2x4 and a 2x2 connected via dedicated optical links, via DCI, via DRCN between the 2 spines. And in here, this is just to show you why we really cared about doing this with our open source software and virtualized SDN-based access and software, is because this is just shows how powerful virtualizing is. So before Trellis in production Comcast, this is what they had to use to serve 192 service groups in their network. When Trellis went into play and our software, the SDN-based ONOS controller, went to manage those same 192 service groups, this is the hardware that they used. So this is just to put you in perspective on how powerful this can be. And this serves a lot of cities and customers in the United States, and it's in production right now. Another project that we have in production that we learned a lot from is the virtual OLT hardware abstraction. We call it Volta for broadband access. And it's a combination of Volta and ONOS. It all starts at the bottom with ONUs and OLTs, so passive optical networks. And then we have the Open ONU, then we have adapters that allow you to manage different type of devices, different type of OLTs, and keep inside the OMCI library as well. And this is capable of handling XGS-PON and GPON. We do leverage between the adapters and the core a Kafka bus, and the core communicates to northbound elements via OpenFlow, and it's all managed by an ONOS controller. This is capable, it's all microservice based, so Docker containers on top of Kubernetes deployment. It has capabilities of handling, as I said, different brands of OLTs and ONUs. Multiple services, so HSIA, voice over IP, video on demand, IPTV, and it has can handle different operators workflow. For example, AT&T, Turk Telecom, and DT, but we're working on adding the Telecom Italia workflow, NTT workflow, and things like that. And we also do have a device management interface for non-data plane, and this is in production with Turk Telecom and Deutsche Telekom in their respective networks, so with live customers. And we learned a lot from this as well. So what are the challenges that we faced in getting these elements to production? What were the humps, the speed bumps that we had to to compensate for during the production deployments and the trials and the testing that we did for all these projects? First of all, is that it's not a project that can handle like 1 customer or 2 customers or maybe even 100. These needs to handle thousands of customers at the same time. So you need to set clear scale goals and iterate over the components to fix them as soon as you get into a scale issue. That we found out how important software update, reliability, and high availability is. So those the lessons we learned is that those need to be built in from the start. And you could leverage existing platforms. You don't have to reinvent the wheel, especially on high availability. There are very good protocols out there. There are very good procedures to do software update to. Don't reinvent the wheel, reuse those. Fundamental are also observability and debugging tools. Sometimes when developing, you forget that the system needs to be managed for a long period of time. And that is really where the operations people can give you a hint. And that's how we did it in our deployment. So we looked into the operations people and what they wanted to observe the system. Also, it's very important that you have a fixed code base in production, that you're not going against a moving target. So you have a minimum viable product requirements, and that you fix long-term support releases. And we did that with Onos, and we're about to do that with Volta with the first LTS release in the next upcoming months. And then I cannot understate the importance of testing. So it's fundamental that you develop how you deploy, meaning that the development environment that you have is exactly identical to the deployment environment that you're going to use for production deployments. That you have comprehensive unit tests for the code, but also integration tests, both on software, virtualized if you can, but also on hardware. Very important because the timings of the hardware are different. That you do soak testing, so extended period of time where you leave your software running there with observing it, that it doesn't crash, it doesn't leak memory and things like that. And then you cause chaos on this software, that you bring down stuff, bring down a server, bring down a service and things like that. So just to give you a perspective, in Volta, we have 170 plus hardware tests on nightly. Also, it's fundamental that you understand the levels of support that you need to provide while using an open source software, an open solution in deployment, because you need to work with the community on these. Before it was just one vendor that would provide the whole solution and you go to the vendor to get support. Here, it's a whole group of community system integrators that work together to give you that support. And on that is fundamental, building a team and sharing the knowledge. So building a team is that you just don't need to keep the people that know about the system a very tight group. It needs to be spread upon the people that deploy it, the community that work with you. And this has to be done at the earliest stage possible in your deployment scenarios. And the same thing for the documentation and the sharing of the knowledge. So it needs to be up to date. This documentation, this information that you have online to show what it does, it needs to be up to date, and always have open meetings and discussions. This is a key point. And this is all to empower and leverage that community. So this was a fundamental key lesson that we learned from our deployments, that we cannot do things just ourselves, but it needs to be involving everybody. One thing that we are now applying these lessons to is what we call the Pronto project. And it's a bunch of universities from United States and funded by DARPA, where we're going to work on the first 5G with verifiable closed loop for government, industry, and education. So if you're interested, just go with this. And all of the things we talked about are going to be applied in here. And not just from a software perspective, from a lessons perspective, this will include all the way from the radio unit, so the base station for the user equipment, all the way to the backbone of the network. So with that, I think I kept it fairly short. I flew through some of these concepts, but if you want more information, just go on our website, opennetworking.org, or you can drop me an email, Andrea@opennetworking, and I think we can take questions later. So with that, I'll give it back to you, Giorgio.
Okay, thank you, Andrea, to stay on time and for a very clear presentation. And now we are going to switch to the operators' point of view. And I would like to start with Akim Autenrich from ADVA, and he will take the floor for his presentation. Thank you, Akim.
Thank you for the introduction and also for the opportunity to present here at this panel. So for me, I would like to focus my talk on the open data models for management and automation of the disaggregated optical networks that we saw in the previous two talks, and to give a few of the challenges and ongoing activities from a system vendor's perspective. So what we saw already is that there are many relevant standard bodies and industry alliances. We had just talks of the two, the Telecom Info Project and the ONF, but there are more base standardization bodies, open source groups, and also industry alliances like OpenConfig and OpenROADM And this, of course, creates also some competition and in many cases also a paradox of choice. In principle, a choice is good to have, but this choice also leads to prioritization because you need to have some effort and to implement the data models, to implement new features. And we heard testing is important, interoperability testing is important, and you need to have a kind of a community of people, vendors, users, operators agreeing on a common model. And this gets more and more difficult the more options you have and choices you have. This slide should show you even more that when you take into account open source projects on the various levels, and these are only related open source projects from the Linux Foundation, then the problem gets bigger, or the challenge gets even bigger, that you have to test out your solutions and integrate them into the different open source controllers, open source libraries. We heard about the Honest SDN controller. There's also the Open Daylight SDN controller, which is part of the Open Network Automation Platform ONAP. So there's a load of integration, development, and testing activities going on, and all of this takes effort and requires prioritization. What will be implemented and tested first, and what will be later implemented. So from our point of view, and these, I just highlighted a few of these, which were used in most relevant in the research, recent research projects like MetroHall, which we will see later on in the presentation. We also had, we were looking at or you already heard about the disaggregated optical network architecture. And this slide should show you the key concepts we already saw. A few of them. What I would also like to point out is that there are different models. There's the fully disaggregated model where each and every individual network element, ROADMs, maybe even down to WSS cards, have their own direct API from an independent end-to-end control. So there is to every network element and every device in the network a direct control, which is we call the fully disaggregated model, for example, in this domain A. You may also have a partially disaggregated model where the analog network is seen as a domain in its own, the open line system domain, which is controlled by a domain controller subtended to the end-to-end orchestrator or vendor-independent control. And then you have network APIs in order to have end-to-end services through this network. And in both cases, we use open terminals with direct device APIs to configure them. We already heard about industry alliances data models like OpenConfig and OpenROADM. And there's also the ONF transport API, which is a network level, offers a few network level services in order to calculate a path through the network or to establish a light path. And for all of these models, you need to have the programmability and automation via open APIs, and we have to stress this. As we have the paradox of choice, and as we have the competition of multiple SDOs and industry alliances, we already heard the most important thing is testing and also interoperability testing. And from my point of view, the very nice thing is that a few of these SDOs are collaborating and aligning and have ongoing active alliances, which are more than just on paper, which are real, backed by real integration work. So the Telecom Info project and the ONF have some joint projects together, some alignment activities, are reusing each other's activities. The ONF itself has a multi-SDO collaboration and is integrating the work together with other standardization bodies. MEF, for example, and OIF does the interoperability test. MEF is directly using the core information model and the TAPI for its lifecycle service orchestration framework. So there's a lot of collaboration and alignment going on. Also, the industry alliances are being used and evaluated and aligned within these projects. So I think these projects are very key and an integral part in order to achieve a success and survivability of these data models, because data models are only successful if they kind of survive and are deployed with multiple operators, supported by multiple vendors, in order to have this ongoing ecosystem. As one example, we already heard from some demonstrations of the ODTN with some proof of concepts. One research project, MetroHall, was actively contributing to the ODTN project, and in this project we also had an ODTN demonstration end of last year, where we had a partially disaggregated notebook. This is only a part of the overall whole demonstration, looking at the contributions where we as ADFA actively contributed to. So we had the domain controller with a TAPI agent for the end-to-end optical network domain services, and a direct API to the terminals using OpenConf. And that was successfully demonstrated and even integrated into an overall virtualization framework using open source Mano for the virtualization, and then the subtended ONOS controller for the SDN WAN control. So in order to make it short, to leave some room for discussions, I just want to stress a few of my views and ADFA views on these the challenges and requirements for a successful ongoing development of this SDN ecosystem. And we already heard open APIs are a key, and open source software is a key requirement. But nevertheless, there exists a whole commercial ecosystem still of commercial SDN orchestrators. But with these open APIs, we do have an active collaboration of different companies. So you see a lot of our, in principle, competitors on this list here above. But ADFA, for example, we are actively collaborating with these other network vendors and software providers for the orchestrators in order to integrate this. So we do have the open source SDN controllers, ONOS, Open Daylight, and also integrated Open Daylight is then the SDN controller in ONIP, but also the integration into commercial SDN, multi-vendor SDN orchestrators. And this is done by using the standardized open APIs, and with the OpenConfig drivers that you have, you can then integrate also your open terminals. So this creates a huge push forward for multi-vendor interoperability. But as the previous speaker was stressing, and we can stress the same, it requires a direct bilateral, multilateral collaboration, also the willingness to cooperate and work together in an environment where you are sometimes also a competitor. But still, this integration is really required. Integration and testing was said before. I can only stress this. Testing, collaboration, integration takes time, so we need to come to a joint agreement on what is the most probable best use case for the different data models. And in the end, it will be a mixture of different data models being used in this SDN ecosystem. Still, what I would like to stress is abstraction is a really important concept in order to decouple the data models from current generation technologies. That means we have an innovation cycle also of the optical layer innovations. We have modulation shaping, constellation shaping, hybrid modulation formats. So there's an ongoing innovation in the physical technologies which you need to support in your data models, and abstraction simplifies this. The deeper you go to the physical layer, the more complex it is. And from our point of view, the partially disaggregated network still provides the best balance between device level terminal control and network level OLS control. With the one extension, of course, you need still to have direct access to the devices for the telemetry, to support AI-based network automation, to support this vendor-neutral optical performance engines that we heard about using GNU-Pi, for example. This is a key step, but for setting up end-to-end services, we still support to use an end-to-end network model. So as a summary, open APIs, collaboration, integration, and testing are really key for successful deployment of network automation and SDN-based network control in the network. Thank you very much.
Thank you very much, Hakim, for the very clear presentation and with the rich points we can address later on during the discussion. So I would like to invite Germano Gasparini from SM Optics to
Okay, good morning, everybody. I'm Germano Gasparini from SM Optics. I will present the point of view of device manufacturers in the context of the open interfaces and the SDN world. I will share my presentation. Just a moment, because I'm trying to share. Okay. Can you see it?
Yes.
Okay.
Clear.
So I will show you the point of view of the industry. Okay, what is the state of the art? Okay, from the device manufacturer point of view, the using network management system for controlling and the network and the devices is established in long. And SDN is just the last step of a long evolution path. And actually many of the concepts that are endorsed by SDN were already well known and used in the real systems, especially for as far as the digital and optical transport networks are concerned. Many concepts were nothing new, but SDN is bringing as a new things, a strong accent towards automation, towards abstracted view, towards virtualization, and towards limiting the human intervention as much as possible, as we saw also in the previous presentation. And to achieve this, a key point is to have standardized management interfaces that are key in a multi-vendor environment. And this goal has always been a target and a challenge at the same time, because it's not easy to match and to find, let's say, the right point where this can be achieved. And there are many organizations that historically was addressing this point in the past, and also there are still active, TMF, OIF, ITUT, ONF, and so on. There are many of them. The management systems, from a vendor perspective and from a supplier perspective, okay, they can be done in many different flavors. There can be something that is provided directly by the supplier. I give you my own management system. So I provide you with the full integration with my own device, but in many cases this cannot be enough, or is not, let's say, this comprehensive solution, because many operators prefer to have, let's say, a composition or integrating different multi-vendor systems, or they want to use their own application, or they want to use their own systems on top, let's say, or of basic management. And also in this case, having an interface standardization is a key in terms of cost, in terms of time to market. If I know what is the interface I have to develop, I will do it faster. In terms of scalability, efficiency, integration. So this is fundamental to have something that is clear in terms of management interface. The general architectural view, okay, when we deal with the network management, we can see that there is a layered view. And here we can see different level of management interface. We will have a management interface directly machine to machine, or between control or machine to application, between network controllers. And that's what typically we call them northbound interfaces. An example for that are the TAPI, developed from ONF, but there are also similar. In past there was TMF, there are other REST Open API, there is TIP, there is IETF-TS. So there are several open, let's say, network northbound interfaces. But in any case, these are devoted, let's say, from the communication from the network controller towards other level of network controllers or SDN application. But then we go down to directly manage the network device. And in this case, we need an interface between the controller and the physical device. These are typically called southbound interfaces. And this will provide the full control, provisioning, monitoring, maintenance, and so on, performance verification, performance qualification, and so on for the network device. Northbound interfaces, as we saw, they operate strongly on abstraction, because abstraction masks completely, or as much as possible, the differences between vendors, and eases the integration from development coming from third parties, because they provide, let's say, a unified and uniform view of the network that can that do not care about the technological details, but focus on something that can be exploited regardless of the underlying implementation. We saw the example before, let's say, in virtualization, let's say, of the optical path. And in general, what we saw, if we look at the network models, we see that the northbound interfaces for this, they rely, let's say, more or less on variants, but the underlying network model is more or less the same, or in any case, that with a very strong similarity. TIS, TAPI, and TIP have a network model that largely overlap. In many cases, differences most on terminology rather than in the concept of support. So this means that even if there are several flavors of these open interfaces, the convergence, as we saw, was also stressed before, is really something that is going on. And normally the industrial products and industrial SDN controllers and industrial application are able also to use and to exploit more than one at the same time. Also, and this is easy also due to the fact that they start basically from the same or practically the same network model, and also in terms of API, actually they are very close. So under this aspect, the situation is really quite consolidated and favoring, let's say, the exploiting of SDN application. But when we go directly to talk with the network device, things are a little bit different, because this is here an harmonization in terms of having, let's say, a uniform view at southbound interface is more difficult because we are, let's say, going to the physical level. So when the vendor specificities actually are exposed at their maximum, they are unmasked, basically. Many vendors have to provide proprietary or exclusive solutions because there is a market and there is a competition. So if I want to sell or to sell better, I have also to try to differentiate somehow from my competitors. So on top of the standards, there is always something which is proprietary, innovative, and so on and so on. And the common abstraction level is more difficult to achieve. It can be achieved in many areas, but a single standardized SBI covering everything is something that historically demonstrated more than challenging. It was attempted several times with different level of success, but it was always very challenging to achieve. Open interface represented the real new opportunity because we are facing this situation. There are some points which are now consolidated. The disaggregated view of the network is a reference paradigm, and okay, we define our network device interfaces based on that concept. The data model that we have in mind for our device is based on this concept. We are integrating in an environment where netconf and open protocols are key. So we are going to use Yank-based data model, which is the technical solution to model, let's say, the data and the view of the network device and its functionalities in a netconf RESTconf based protocol environment. But if I will look for one single model covering, open model covering everything I need to manage my equipment, the point is that not yet. We don't have it yet. The reality is that we have OpenConfig that is strongly becoming one of the reference protocol because it has very good coverage as far as networking protocols are concerned. It's supporting the disaggregated view, so it's functional for that. Some key functions such as telemetry. Okay, the telemetry based on OpenConfig is actually the real standard, industry standard de facto. So this is something that is clear. But if we look at the coverage of OpenConfig, there are still significant functional gaps because there are parts of the transport network, like let's say OTN technologies and other technologies that have their own complexity that are not yet covered at their full extent. So here we have a problem. We have to manage this. OpenROADM, again, is another open standard, has widened its original scope, but it is still intended for specific network application. And again, it does not cover everything is needed. So the bottom line, what is the result is that if I want to have the full control of a network device, I need always something else with respect to the existing open interface model. And in most cases, this something else means something proprietary. So for as far as southbound interfaces are concerned, there are still some path to go in order to achieve, let's say, the same level or a similar level of commonality and abstraction that was already achieved on the northbound interfaces. But in any case, there are very important benefits that we recognize when we deal with the open interface. As said by Andrea, we do not need to reinvent the wheel. If I have to provide a data model, the first thing I want to do is, okay, let's look if I have already some open model available covering my feature. So I can use OpenConfig, I can use IETF module, I can use OpenROADM modules, and I can make a composition so that wherever possible, I rely on the existing open interface. This is also time saving for integration, because either these models are already covered, or if I need to use young techniques to add specific extensions or specificity, vendor specificity, I can do it and integrate seamlessly using, let's say, exploiting the capability that systems such as Open Daylight and ONOS are able to automatically produce. In the past, to integrate, let's say, vendor-specific solution, the network manager had also to produce specific code in order to support this. If I have a data model based on YANG and I want to expose something extra from the YANG model, I can simply load my YANG sources on the systems. They are able to automatically generate the APIs to control this. And if I don't need the user interface, which is the case of SDN environment where automation is the key, I have practically already integrated, or with a very less effort, I have integrated my specificity in an SDN environment. So this is a very big improvement. And last but not least, if I am producing many products or different products, if I decide to use the same model everywhere, okay, I'm supporting the concept of the family concept. Well, that means that the same feature is managed in the same way, whatever is my product in the family. SM Optics is a relatively young company because we started our activity in 2014, and our products were since the beginning conceived to be only SDN-based products. So we do not exploit, for instance, SNMP VIBs. We do not exploit the TL1 concept. We only use for the management YANG-based data models. We had and for that, when possible, we used, I said, standardized or let's say available open models. Where these available open models were not ready or not yet available, we decided to use for our data modeling the ONF core model as a reference. It's still a proprietary solution, but it still relies, let's say, on an open definition and on an open model that can be easily then also adapted to other models like TAPI not bound, because the similarity is there. We have, let's say, a domain controller that is able to provide not northbound TAPI and other open API, and we have, let's say, a strong integration with also other components. And our solution is exploiting all the benefits of the open interface and all the, let's say, SDN modeling and available, let's say, open models. This help us to achieve our managed system in a time to market quite faster than in the past. This was our experience. I don't have any further further presentation.
Okay, so thank you, Germano, and I think now is time to give the floor to the operators, which are in some way the end user of all this technology. And I would like to start with Juan Pedro Fernandez from Telefonica. And please, Juan Pedro, can you take the floor?
Thank you, Giorgio. I'll share my desktop. Okay. I hope you can see my screen. Can you see it?
Yes.
Okay, good. So I think I have to say that I was following with lots of interest the previous presentations. I think my presentation is totally in line. I think most of the messages are common. And okay, the main purpose is to present, first of all, what is, from the Telefónica perspective, an open optical network, what is our target, and what we are working on that. What is needed in order to implement an open optical network. And third, what are we doing, and also in collaboration with other operators in a new group created in the Telecom Infra project, this MAST, where we are defining the technical specifications for both the northbound interfaces and the southbound interfaces that are needed in order to enable this open optical network. I will start, with explaining what is an open optical network. Basically, I think both Germano and Achim talk about that in their presentation. Is a network where we have open and standard interfaces, enabling on the one hand the network programmability. This is typically the northbound interface, so that software developer could interact with the network with the same interface, providing some network abstraction independently on the vendor, so a common programmability interface. And second, standard interfaces for device configuration, the southbound interface, enabling also a vendor agnostic SDN control. Currently, this is, I think, the 99% of the networks are aggregated ones. The approach is totally different. We have aggregated networks with transponders, ROADMs, amplifiers, every single element from provided by a given provider, and also including a network management system or an SDN controller, which configures the network and provide these proprietary interfaces towards the network applications. This means that if we want to introduce, for example, a new performance monitoring platform, artificial intelligence, or inventory tool, or whatever, we need to do ad hoc software adaptations for each vendor. On the other hand, in an open optical network, the situation is different. On the one hand, it is implementing a standard northbound interface. Particularly in Telefónica, we are using TAPI. We selected TAPI as a standard and common interface from the optical layer to the OSS or to the other network applications. So that we can integrate, or we can introduce these new tools or applications working with the network. We can use the same applications without software adaptations in any country in Telefónica with any operator, so having a common and standard programmability interface, and this is TAPI. And secondly, in order to also to enable the disaggregation, having or vendor interoperability, we need also a standard southbound interface. Also, Germano talked about that. This southbound interface, in particular in our case, we are just focusing on the southbound interface to configure open terminals and enabling the partial disaggregation. This is because this is the main use case we foresee. The idea is we decouple the optical transponders from the open line system. Then we can promote the innovation. We can have more alternatives in the transmission segment. We can use optical white boxes, data center interconnection solutions, or optical channels from different vendors, while very important, keeping automation. Currently, of course, we can have partial disaggregation in a network. The alien wavelength is something that is not new, but the problem with if we don't have a standard SDN, if we don't have these configuration, these interfaces, then we have to manage that manually. We have to establish the light paths. We have to do. We need lots of manual interventions in order to have this to implement this alien wavelength. And on the other hand, for example, we are losing capabilities like Automated network discovery, dynamic restoration is something that is not possible in a, let's say, typical disaggregated network of current existing disaggregated network with alien wavelengths. However, using SDN, using standard interfaces, using in particular OpenConfig modeling to configure the open terminals, then we can have disaggregated networks with open terminals from one vendor and open line systems from other different vendors, and keeping automation, automated network discovery, inventory, performance, fault management, and restoration. So, what is needed? What is the key in order to implement the key elements to implement an open optical network and enabling this partial disaggregation? Are both the interfaces. On the one hand, we need, of course, an SDN controller in the open line system. We need a SVI and a standard SVI. In our case, we are using OpenConfig for that purpose, and a standard SVI to configure the open terminal from the SDN controller. But we have two options, because not all the vendors are ready or are willing to implement the softbound interface in the SDN controller. For those cases, we have also another option, that is where the open terminals are configured by an external controller, a hierarchical controller typically, which configures the open terminals using OpenConfig and configures the line system using TAPI, everything with the standard. So one of the questions could be, okay, this is just a target, this is just a dream, or is it feasible? The answer is yes, it's feasible. In particular, in Telefonica, we hosted the SDN interoperability events in 2020, and the work on this event was focused exactly on these topics. On the one hand, we did an intensive work on testing the TAPI and different use cases for TAPI in aggregated networks, but we also tested and did some demonstrations with different combination of vendors with open terminals or open line systems, and automated operation, automated service provisioning, restoration, service discovery, and so on. Due to the lack of time, I will not go into the details of this this test. Just to mention that, okay, for example, in the open terminals, we work with Cisco, Siena, and Nokia. In the open line systems with ADFA, Nokia, Siena, and Infinera. In this case, we had both the domain controllers and also hierarchical controllers. So with in the hierarchical controller with Siena, Cisco, and Nokia, and we tested different situations. For example, going very briefly in terms of TAPI testing, and in this case, the TAPI testing was focused on an aggregated network. We tested how the support of the standard, in particular the TAPI 2.1.3 release. In this case, for this release, Telefonica was very active or intensively working on the technical specification of this release for the use cases. The idea is, at least the approach we are following in Telefonica, and we are also expanding or extending to MAST, is working using a use case methodology. We're going use case by use case, for example, covering discovery, provisioning, inventory, resiliency, the different use cases that we need in the day-by-day operation. And for each use case, we provide a specific technical specification that in this case was included in the RIA, in TAPI, and once standardized, that was also implemented by the different vendors in the interoperability event. I have to say that the level of support of this RIA was really good, mainly considering that, for example, the release was published in July, and this test starting in September, and most of them were done in October, November. So also a good message or important result that the vendors could implement this quite fast. If the specification is clear, the implementation is fast. We also did testing with the open terminals. in order to, in this case, we tested some also basic operations, discovery, provisioning, service deactivation, or telemetry. I will not go into the details, but the idea is we use OpenConfig modeling. Once again, the target was only configuring the open terminal, only the transponder. The rest of the network, the open line system, is expected to be configured by the domain controller using each vendor interface or mechanism. And the level of support of the OpenConfig in the open terminals was really good. And also the accuracy in terms of I think most of the vendors are really supporting this idea, and also the implementation of OpenConfig seems to be feasible. Okay, so once we have tested the OpenConfig, the southbound interface, the northbound interface, the open optical networks are feasible. Anyway, we have lots of work to do in order to have a complete specification covering any use case that an operator may need, and of course we need a standard solution. In order to speed up the implementation of these standard solutions, we have created a group in the Telecom Infra project. The idea was we coordinated with other operators with the same goals, with the same ideas. And the idea or the target was, okay, if we are looking for a standard interface based on use cases, let's align what are the use cases, common use cases among us. And let's, I think as also Germano mentioned, not to reinvent the wheel, but take what are the models that are available in the standardization forum, something that is mature. And if we can, let's try to build up the use cases using these the existing models. And if we identify a gap, let's work together in order to complete it. According to that, okay, if you visit the TIP webpage and the OOPT, the Open Optical and Packet Transport, then you will find all the documentation about MAST. There is a white paper describing the methodology, the architecture, and the selected standards. And you can also find already the first deliverables. The first deliverables where we are providing the technical specifications. For example, in the optical layer, the first deliverable was focused on the northbound interface, on TAPI, is including the technical specification for a set of use cases, mainly service discovery, inventory, and service provisioning. You can find this document in the web page. And now we are submitting, I think by the next week, we are submitting the deliverable with the southbound interface specification, with the OpenConfig parameters that are needed in order to also to cover these use cases in a partial disaggregated network. Our target is to release periodic deliverables, one per quarter, with incremental use cases. And the idea is to provide a guidance to the industry saying, okay, there are lots of standards, there are lots of options in order to implement, for example, an open optical network. We can provide a guidance of what is a way to do it, or at least coordinated among different operators in order to cover specific use cases and using standards or models that are mature to implement them. Just to conclude, mention that, of course, manageability, flexibility, we need dynamicity in the optical networks, in the transport network for the operators is a must, mainly now with the introduction of the 5G. On the other hand, disaggregation on open transport, open optical network would enable an agile introduction of new technologies, new suppliers. There are many new. We have a very dynamic market in the transmission, including solution for data center interconnection, white boxes, so on. The introduction of these networks, of these solutions, could be much easier if we have an open optical network with standard interfaces. And then it is, okay, we can have both dynamicity, manageability, flexibility in the network and disaggregation if we have the right and a standard SDN architecture. According to the test we did in the SDN interoperability test, I think we demonstrated that, okay, this is feasible. This is, we can do it. We can have the specification for the northbound and the southbound to enable that. And now the key is, but something very important is that this is something that should be, we need a strong involvement from the operators. I think in our case in Telefónica, we were working a lot on the detailing the technical specification for the TAPI, for the open config, what are the parameters that are needed for each use case. And the idea is also aligned with the other operators in MAST in order to have a common specification and speed up the standardization and the implementation by the vendors. But this is something that in order to go step by step with something useful, we have to go in using a use case methodology and lead it by the operators. Okay, that's all from my side. I don't know if I exceed my time.
Okay, thank you very much, Juan. And I think that, okay, now is time to give the floor to Christian Jagnet from Orange, that will report his experience on the field.
Thank you, Giorgio. Hello, everyone. Okay, so can you see the slides?
Yes.
Yeah.
Okay, cool. Okay, so I realized that in the company of distinguished optical network experts, which I'm not, I'm more of an IP guy, which means that my presentation may sound slightly different from what has been presented so far. Nevertheless, I do share most of the conclusions that were exposed by the previous speakers. The thing is that this last presentation was really meant to share some of our concerns when it comes to introducing automation in the overall service delivery procedure and operation. So a very basic introductory slide that basically recaps the promises of network automation, the ability for the operators to dynamically program networking infrastructures and resources in order to accommodate the different customers' requirements that may arise, and whether the end users may be in motion or not, and regardless of the networking infrastructure, be it an optical network, an IP MPLS network, and when it comes to the delivery of what I would call inter-domain services, such as VPN services that may span across domains, we have to obviously consider the ability to dynamically program the resources that will be involved in the actual provisioning of that kind of service. And this is, I think, especially critical in this era of 5G network deployments based upon this notion of network slices, which may indeed span different domains and may also involve different parties, tenants, as well as third parties, who will be responsible for the actual allocation of the resources of the network slice, again, to accommodate the requirements that may have been expressed by the end user and the customers, and which may also have been dynamically negotiated. So I guess, and I'm afraid, at the risk of sounding a bit pessimistic, that the reality is way different from the promises that have been largely documented and promoted for the past decade. The first thing is that as an operator, we still have to deal with mainly declarative tasks. One iconic example is the processing of the service orders that are stimulated by your end customers. if I get back to this interdomain VPN service example, for example, it becomes even more complex because you have to negotiate with partnering service providers, for example, to make sure that they will be able to allocate the provider edge resources that would be involved when it comes to configure the virtual routing forwarding instance that will reflect the VPN routes that can actually connect the CP of the end customer, the corporate customer, in a network or to a network which is not operated by the actual VPN service provider. Another very typical example, which may sound a bit classical to some of you, is the configuration regarding the massively scalable data centers. When we choose to move from a basic, I would say, layer 2 forwarding policy towards a BGP-based forwarding policy because of the CLO architecture, which is really typical of that kind of data center on one side. And this also, on the other side, assumes that you've got the ability to dynamically assign the autonomous system numbers, and you have the ability to dynamically establish the BGP sessions and to define and enforce the import and export routing policies that will basically help you master the traffic flows that will correspond to the access to the different contents hosted in the virtual machine servers, as well as the virtualized functions. And the reality is that that kind of automation does not exist today. We still have to face with a set of pretty complex configuration files, which are sometimes made of hundreds of configuration lines. And even though you could use a standard protocol toolkit to facilitate the provisioning of that kind of configuration information towards the participating components, you still have to deal with that kind of manually declarative tasks, which obviously affect the overall performance when it comes to the actual service delivery procedures. On the other side, we do have, and which is really good news, a few standard data models. This is something that has also been mentioned by the different previous speakers. But the thing is that, as already mentioned by some of the speakers, we still have to deal with technology-specific environments, which means that when it comes to considering the nature of the underlying infrastructures, you need to be very careful about the actual manipulation of the appropriate data model in order to take full advantage of the different capabilities which may be vendor-specific. Obviously, during the old days of SNMP, we have compiled many enterprise MIPS, which were meant to precisely reflect the technology-specific environment that we use. And I'm afraid that even though we still have, we can still observe a pretty good progress in the standardization of open data models, we will still have to cope with some technology-specific capabilities, which might again possibly affect the performance related to the introduction of network automation techniques. Another example I wanted to share with you in this slide is this notion of dynamic service parameter negotiation capability. This is, as an operator for us, it's of a critical importance, because obviously we want to make sure that the customer has access to all the parameters that he may be able to express in terms of requirements, for example, quality of service requirements, security requirements, traffic forwarding, or even traffic routing policy requirements, which to us will be again of primary importance when it comes to the deployment of 5G network slices or complex VPN service offerings, architectures, for example, which require very different capabilities and which may reflect the actual requirements and concerns of the VPN customer. And the whole point, as far as automation is concerned, is that the outcomes of a successful dynamic service parameter negotiation is meant to feed the computation logics that would be involved in the actual resource allocation and policy enforcement schemes that will be presumably service inferred. So like Germano said, for example, some of the techniques that will be involved in this overall global introduction of network automation techniques have been mastered for quite some time. I'm especially thinking of what we used to call policy-based management. It has been standardized in the early 2000s, and which were primarily focused on dynamic resource allocation schemes and also the ability for what we called at that time a policy decision point, which could be denoted as an SDN controller, if you will, in this context, as the ability to make decisions and to dynamically instantiate service-inferred policies that will exactly reflect the requirements that may have been expressed by the customer. But to this day, if I take the example of what has been published by the TM Forum on one side or the Metro Ethernet Forum on the other side, as far as service order management is concerned, there is absolutely no room for dynamic negotiation. So this means that it's a black and white situation in a sense that if you want to accommodate the requirements of a survey of a customer, you need to make sure that you do have the available resources within the network. Otherwise, you will have to decline the request from the customer simply because you don't have exactly what the customer has requested in terms of resources. And we believe this is a pretty important drawback if you want to precisely be flexible in terms of network programmability and again to exactly accommodate the customer's requirements. So our view in terms of global network automation framework is something which has been also quite extensively documented for the past years. But I really wanted to very much insist on the fact that it's not only a matter of defining the nature of the information that will be exchanged between the control plane and the data plane, what some of you have already mentioned as the so-called southbound interface. It's not only a matter of defining the nature of the information that needs to be exchanged between the management plane and the control plane, which some of you have defined as the northbound interface. It's a more global thing from the ability to dynamically expose the service parameters and to provide the ability to dynamically negotiate these service parameters, for example, based upon techniques like intent-based networking, where you would have a slice of artificial intelligence to precisely interpret the requirements or the intent which has been expressed by the end customer into something which looks like one of the services you provide as an operator. And then the orchestration logic that would typically reside in the management plane would be responsible for dynamically structuring the corresponding service, which again is meant to reflect the intent that has been expressed by the customer. And then again, once the service is identified, then you would invite the customer to dynamically negotiate the parameters of such service to once again be very precise in the actual accommodation of the requirements that will pertain to this service. And then once the service is dynamically structured, then this would be the responsibility of the computation logic that resides in the management plane to instruct the SDN controller so that it can proceed with the corresponding resource allocation as well as policy enforcement. And again, to make sure that what has been delivered complies with what has been actually negotiated, then you would need the appropriate feedback mechanisms as well as control loops so as to make sure that the whole system is properly deterministic. So it's really a global picture I wanted to share with you, meaning that even though some of the techniques that comprise the global network automation framework are already available and to some extent pretty well mastered so far, there are still gaps in this global automation framework that needs to be filled in order to be really confident about the ability of your network automation system to exactly accommodate the requirements of the customer and obviously to also facilitate this flexibility argument that was largely promoted when the notion of software-defined networking appeared at the end of the first decade of the 2000s. So to conclude, this is really a kind of wish list, if you will, or a set of challenges that we still have to face. again, one really key message I wanted to share with you today is that we still have to be global in the overall principle of introducing network automation. It's not only a matter of provisioning the configuration information to the participating components from the control plane where the SDN controller will reside, and based upon hopefully standard data models and open interfaces, as rightfully mentioned by the previous speakers. It's also a matter of keeping a global view of the overall service delivery chain, again, from the expression of intent by the customer to the actual service fulfillment and assurance mechanisms that will be invoked to, again, make sure that what has been delivered complies with what has been exposed and negotiated with the customer. Openness is obviously key. This is one of the key topics of this panel. But one thing which is important to us is really the preservation of our savoir-faire. I've been involved in the specification of several young data models. One of the most recent is the layer 3 service data model, which is being specified by the ATF for the time being. And this is really the opportunity for us operators to explain how we design a VPN service or even a 5G network slice as a service paradigm. And the way you conceive the data model is really an opportunity for us to reflect our savoir-faire, and again, regardless of the underlying technology. And from that standpoint, our experience of open source projects, some of them have already been mentioned by the previous speakers, is that obviously we see a tremendous opportunity to progress the specification effort in that area. But we also think, and we sometimes observe, that some participants to some of these open source projects may have very different business interests than ours, and this may be a risk to hinder the research in that area instead of dramatically progressing the research. So it's really important to not only preserve our savoir-faire, but also to make sure that every participant to an open source project can take full advantage of the research that will be conducted within this project. Of course, artificial intelligence can help, but this really demands extreme caution, not only from a performance and scalability standpoint. It also really depends on what you want to do with the use of artificial intelligence, because it can lead to very complex and risky situations where you may lose control of what's going on as far as the service delivery procedure is concerned. So we are investigating the use of artificial intelligence, for example, to anticipate attack mitigation in our networks. We have developed some models and especially some design recommendations regarding the use of specific algorithms, machine learning algorithms in that area. But we also realize that the manipulation of that kind of algorithm, let alone the corresponding parameters that need to be processed for proper neural network design, is also of critical importance. And last but not least, obviously, very briefly, I've tried to expose some of the gaps that we are currently have to deal with, we still need to be pragmatic. There was Juan Pedro, for example, mentioned the MUST initiative, and he also highlighted the discovery phase. This is something that really echoes what some of the work I've been involved in, which is the SDN bootstrapping. What happens when you switch on the SDN network? What would be the time zero image of the network? And what kind of information needs to be accessed by the SDN controller? This is an area which has been quite poorly investigated so far. Service parameter negotiation is another one. And one primary area, which is also quite often for the time being, is the security. So I will just conclude here. Thank you very much for your attention, as I realize that we are already 5 minutes behind the schedule. Thank you.
Okay, thank you, Christian. And this was the last presentation of our panel. I believe it will be very interesting, and thank you to all the speakers for sharing their experience. Just I would like to comment about the presentations. I believe that we realize that from one side we have a very enthusiastic view of the developer of open framework. I believe this will create also opportunity for new business model and new actors in the field. And from the other side, we see the reality of the actual implementation, and so we are in some way at the beginning to use this technology in the real networks. And there are still open issues. I would like to mention, for instance, performance issue. We have, when we put together a different framework and we need to make them talking together. And so we have, for sure, efficiency issue. We don't touch very much security, which is another point for sure very important. And also all the operation, maintenance, and support of the network will be in some way should be addressed within this framework. So thank you again, and I'll leave to the attendees some question for the speaker. We are a little bit out of time, but since I believe it's very interesting panel, and with Guido, I think we can devote some more minutes for questions.
I agree. So if there are no other questions in the slide, in this chat, I don't see any. I would like to break the ice with a question of mine. Let's say this question is to all the speakers, but maybe Achim is more addressed to Achim. This very rich time with all these different choices and drafts of specifications for modeling of devices seems to let's say evolve, most probably in a future where there will be a natural selection of models in order to maybe reduce the different choices and possibilities. But you, in any case, mentioned a sort of competition between the different models and the organizations that are supporting them. So do you think that this competition will be based more on the technical quality of modeling specifications, or more on market and commercial, let's say, considerations? So this is my general question.
So if I may start with the answer, I think the question is very interesting and not so easy to answer with a clear yes or no. The usage of standardized open interfaces very much depends also on the support from different and usage by different operators, vendor groups. So it's not necessarily that the best technical data model will win in the end, but it's more the agreement of many players, operators, vendors, to use that model, which gets an alignment and which gets the required volume and number of users in order to make a data model successful. On the other hand, it also requires ongoing support and further development of the data models. Otherwise, they tend to get outdated over time, and other models come in. Unfortunately, I don't believe that we are in a linear way where we agree and align and consolidate the networks, and in the end have only one or two data models left, because there's always ongoing innovation, and there's always striving to improve some data models, to come up with new data models. So we will have always this race of realizing and deploying existing data models, but also looking into the future, what is missing, where are the gaps, what do I have to do new, what are new technologies which we support in order to support and develop the data models. So it's never clear from the beginning who will win, and it's a kind of a community exercise.
Thank you.
There are the questions from the participant.
Sorry. No, sorry, this is Juan Pedro. Just to add something about the previous question, and I totally agree with him. I think okay, at the end, the telecom operators are the final customers of this, and from our side, for example, why in Telefónica we selected, for example, TAPI and OpenConfig modeling. The reason was, okay, there was lots of options. We selected one that was we selected one option for the SBI and one for the MBI that was the more mature when we took the decision in order to implement specific use cases. So usability, we need something. The key is having something that could be useful for the network operator, and that could be implemented and put into production. And then what is key also is an active work from also the customers at the end, is the users, the telecom operators, to work on the specification of this modeling for the use cases that they need. And this is, for example, this is what we are doing in MAST. That is, if we have something, for example, now in Telefónica Germany, we are deploying optical disaggregation using OpenConfig and using TAPI with channels from one vendor over the optical network of another vendor. Is something that is already in production, and that was mainly because we were also pushing and working on the standardization and defining what was needed in order to do that. It's not a question of I think there are different models that are all of them are fine, but it's important to have also an alignment based on use cases that could be useful for the operators in order to speed up or to start the production. The first things or the first models that are put in production, I think, are the winners.
Thanks. If there are no other questions, maybe I have another one. So mainly for Christian. I think that what you have mentioned about the issues that arise from the problems in fine-tuning parameters is very important. One possible way that could be provided in order to overcome this problem is that when you are trying to set up some new service, you may first try to make it working in a best effort way, and then maybe later you try to optimize the different parameters. So this approach, for instance, can be online with having a reactive control plane and a management plane that takes the decisions fast, and maybe then use some re-optimization tools in order to fine-tune parameters, maybe also using some algorithm that takes time. So how do you think about, what do you think about this possible solution?
Thank you for your question. I'm admittedly a bit concerned with this notion of best effort, mostly because the SDN architectures that we've deployed so far primarily relate to what I would call advanced service offerings, which means that, for example, the VPN service offering that we provide, which was opened in 2016 based upon an SDN architecture, let the corporate customers to really express their requirements in terms of quality of service and security, which means that we could not afford a kind of I would say best effort based service design, so to speak, because we had to deal with the nature of the traffic patterns that would be forwarded and specific to the VPN, and which may sometimes have very constraining requirements in terms of latency, for example. So this means really that, and to be maybe to be more specific in my answer, I think this first starts with the exercise of what I would call an information model. The information model, contrary to the data model, is something that we use internally to really depict as precisely as possible the service that we want to provide, and to assess the efficiency of the model against the the different levels in the tree structure that will reflect the different components of the service. So if I take the example of the VPN service offering, you would have a forwarding branch and a routing branch, which would reflect how you will, for example, configure the VRF instances. And then you would have a security branch where you would use the IPsec protocol suite along with other mechanisms to secure the data flows that will be forwarded through the infrastructure, etc. And this assessment phase somewhat looks like some kind of embryonic continuous integration, continuous delivery spirit, if you will, in the sense that when it comes to actually designing the service, we'll have that kind of testing experience so as to be hopefully as much confident as possible when comes the time to actually deliver the service to the customer. And of course, like you said, during the operation phase of the service itself, there may be different events, for example, the addition of a new site as far as the VPN service is concerned, or a leak failure within the underlying networking infrastructures, which the computation logic will be aware of. And this may lead to the dynamic distortion of the decision-making process, for example, trigger a new resource allocation cycle to accommodate the link failure. And this would be based, for example, about tools like the BGP-LS protocol, which would be used between the control plane and the data plane to exchange information about the IGP metrics that will be used in the network, and again, to best accommodate the event that may affect the overall service operation. So to make a long story short, my answer would be first, we rely upon information models in advance, a priori, if you will, to assess the efficiency and the precision of our design as far as the service is concerned, to best accommodate the customer's requirements, may be extremely constraining, which means that we do not plan to, deploy a kind of best effort service in the first stage and then see what happens after 3 months of operation, for example, to retune or refine tuning some of the parameters. We start, I would say, from an abstraction of the service itself. We assess this abstraction, and then we deliver according to the requirements of the customer. And during service operation, we indeed adjust and fine-tune the parameters of the service, for example, by means of triggering new resource allocation cycles, to again accommodate the different events that may affect the operation of the service, and which may intervene during the lifetime of the service itself. So it's a kind of smart combination between advanced design based upon proper information models on one side, and the use of continuous integration, continuous delivery paradigms on the other side, to again best accommodate any event that may alter the operation of the service.
Okay, thank you. Thank you very much.
Okay, I don't know, but I think we are more or less out of the time. We started with the new time and we finish with the old one, so we spend a couple of hours. I would like really to thank you to all the speakers that, let me say, build a very interesting session and discussion, I believe, and I hope that it was interesting for the attendance and for the participant. So thank you again, and okay, hope to see you in next time live.
So thank you very much, Giorgio.
Thanks, everybody.
Speakers.
Thank you.
This was really an interesting and very, very nice panel. I would like just to remind you, all the participants, about the gather.town virtual poster session of this afternoon, where you have also the opportunity of doing a short virtual visit to our lab. And then I also would like to wish you a nice lunch. So just to follow up what I shown in the previous days. The first day was pizza. Yesterday, risotto alla milanese, which is a typical 4-course dish from Milan area. For today, I have prepared cassola, which is a 2nd-course dish. And so with this, sharing this slide, I would like to leave you to the lunch. Unfortunately, we don't have so much time, but I think we can resume our program at 1:50, just to be a little bit late for 5 minutes. On 1:50, we will have the keynote, the 3rd keynote of this conference by Dr. Gino Masini. So have a nice lunch and see you later. Thank you.
Okay, thank you, Guido.
Thank you.
Thank you all. Bye-bye.
Thanks. Bye.